Subtopic number 5, resistors in series and parallel. So we've learned about capacitors in series and parallel. Now we have to learn about resistors in series and parallel. So you have to determine the effective resistance of resistors in series and parallel. Okay, so resistors in series, this is how it is connected, and this is for parallel. So if you see the drawing of the current, so we know that the current will be equal across all capacitors. Okay, so this will be equal, this will be equal, bukan be equal, tapi the current will be the same lah. Okay, so the current is equal across each resistors, but for parallel circuit it is not equal. So this is I1, this is I2, this is I3 lah. Okay, can you see the diagram? Never mind, you can see it. So for the series circuit, the current is equal, but the voltage is shared by the three resistors. So V is not equal. V will be equal to V1, V2, and V3. So the effective resistance is then equal to R1 plus R2 plus R3. So in general, this is how you determine the effective resistance lah. Okay, so the value of effective resistance will always be greater than any of the individual resistance lah, sebab ni kan tambah mestilah dia greater. Okay, untuk parallel circuit pula, for parallel circuit the voltage will be equal across each resistor. So this will have the value of V, and V, sebab di sini sudah V. Okay, so dorang akan ada the same value of voltage. The current, however, splits into separate paths, as we can see here. So we have I equal to I1 plus I2 plus I3. So the effective resistance is equal to this equation here. So the value of effective resistance pula mesti less than the smallest resistance in the group of resistors. Okay, now let's look at example 8. So basically, you have to be able to remember what is the characteristics for resistors in series and in parallel. Kalau kamu tidak dapat ingat, kamu tidak akan dapat solve any of the questions. Memang susah untuk kamu solve. Okay, so example number 8. So now we just have to determine the effective resistance of this circuit. So remember, we have to kasi tinggal dua aja resistor lah. So kita akan solve this one first, baru this 3 begitu. Okay, alright, so the effective resistance for this one is gonna be equal to, I don't know if you will be able to understand if I do like this. Nanti susah pula. So this is R1, R2, R3, R4. So we will do R2 dengan R3 dulu. So this is connected in parallel. So that is 1 over 6 plus 1 over 6 to the power of -1. So the equation will be the diagram will be like this. So this is connected in series, so it's gonna be the addition of R1 plus R4 plus R2 3 lah, sebab it is in series. So this R1, this is R2 3, this is R4. So kamu akan dapat 3 plus 5 plus 1 over 6 plus 1 over 6 to the power of -1. So this will be equal to 11 ohm. Okay, so sama juga macam the second diagram, tapi dia just ada additional 1 di sini. But what you have to do is, this is gonna be R3, 4. So 1 over 12 plus 1 over 6. So the effective resistance is R1 plus R2 plus R5 plus R3, 4. Okay, so yang ini dia akan jadi satu di sini, di sini dengan di sini. Okay, dia punya diagram jadi macam ni lepas kita simplify. So this connection is in series, so we just have to tambah yang di sini ni lah. Okay, so kamu akan dapat 3 plus 6 plus 5 plus 1 over 12 plus 1 over 6. So the effective resistance is equal to 18 ohm. Okay. Alright, so that is on example number 8. Now we have to look at example number 9. So this is not really complicated, but you just have to know which one should you solve first lah. Okay, so what I would do is I'm gonna do it towards the battery. Okay, so we are gonna do this one first. So this is R41. And then the diagram will be like this. Okay. Lepas tu saya akan buat, I'll solve it this way. And the diagram will be looking like this. Okay, macam tu lah. Last baru kita dapat determine the effective resistance. Okay. Alright, so this is R417. So this one is R15. This will be R417 dengan R15. Okay, so let's calculate R41 that is in parallel. So it's going to be 1 over 4 plus 1 to the power of negative 1, which is 0.8 ampere. And then R417 is in in series. So that is 0.8 plus dengan 7 ohm. So you will get 7.8 ohm. Why did I put ampere here? This is ohm. Okay, lastly, the effective resistance is in parallel. So it's going to be 1 over R417, which is 7.8 plus 1 over 15. So it's going to be 5.13 ohm. Okay, so maksud saya tadi tu, this is R7, this is R15. Begitu so dia punya numbering. I'll follow the value of the resistance. Okay, so that is how you solve for the effective resistance for example number 9. Example number 10. Figure shows an arrangement of 4 resistors connected to a 20 volt battery. So we have to calculate the effective resistance and the current that flows in the 3 ohm resistor here. Okay, so for the effective resistance, firstly we are gonna simplify these 2 resistors here. So I'll label this as R13 lah. Okay, so now, so bear with me on how I'm writing because I've hurt my thumb. So I am actually writing with a painful thumb. Okay, alright, so for the effective resistance, it's gonna be R13. So this is connected in parallel, so it's gonna be 1 over 1 plus 1 over 3 to the power of negative 1, which will give you, oh, I didn't calculate it. I'm not gonna calculate that, but basically after simplifying it, we will have a diagram that looks like this lah. Something like this. Okay, so after kita simplify R13, kita akan dapat diagram yang macam ni. So this is connected in series, so it's gonna be, okay, it's gonna be R13 plus, so this is R2, this is R4, it's gonna be R2 plus R4. Okay, so it will be, oh my god, my thumb is actually quite painful. have to do this because next week we will be entering chapter 3. So you will get 6.75 ohm as your effective resistance. Okay? Okay, lastly, we have to determine the current that flows in the 3 ohm resistor. So that is basically this one here. We have to determine the current. So we know that the current that flows from here, so it will be splitting at this junction here. So you will have different current here, a different current here. So it's gonna be I1, I2, I3. Okay, but basically the current that flows here will be just I. Day, melampau juga tu, tapi biarlah. I1. So it will be I1 juga lah. So across here will be I1 as well. Okay? Alright, so now why do I say that the current here will be the same? It is because we know that for series circuit the current will be constant. Okay? So firstly, in order for us to determine the current that flows through here, we have to determine the current that is flowing through this circuit here. Okay, so how do we do that? Is we are gonna use the Ohm's law, which is V equal to I R. Okay, so the current that is flowing here is I1, so I'm gonna label it as R1, and the effective resistance is the one that we will be using. So it's gonna be, oh my god, this is painful. Oh, that's kind of loud. Okay, so this is gonna be V over REFF. So this is 20 over 6.75. So the current that is flowing through the 3 resistors are 2.96 ampere. Okay, so sekarang ni macam mana kita mau determine the current across the third resistors is we are gonna use the equation. We are gonna use this equation. Okay, so apa yang kurang di sini? Kita teda the value of V3. What is V3? V3 is the voltage across this resistor here. Okay, so each of this have its own value of voltage. Okay, they don't have the same value of volt lah. Okay, so macam mana kita mau cari tu? First, kita perlu tahu the concept of voltage across the series circuit. So untuk series circuit, we know that this is a series circuit. For series circuit, the voltage across them are equal. So equal pula, sorry. So it will be V1 plus V23 plus V4. So apa yang dari mana saya dapat tu equation is I've created it based on this here. So ini adalah V1 pula kan saya tulis. It's gonna be R2 lah. Wait. Ini 3 ngam. Okay. So it's gonna be V2. So it follows the value of resistor lah. Okay. Boleh kah? 1, 2, 3, 4. Boleh lah. Kita kasih label dia macam ni. So this will be R1 lah. This is R1. This is R23. This is R4. So this will be V across resistor 2. This is V across resistor 4. Okay? Alright. So sekarang ni this is the voltage across resistor 1. Voltage across resistor 2 and 3. And voltage across resistor 4. So this is V. So the value of each of these will be equal to 20 volt. So sekarang ni, kalau kita sudah dapat V23, kita akan dapat V3. Sebab kenapa? Sebab untuk parallel circuit, which is this one here, for parallel circuit, what you need to know is the voltage across the resistors will be equal. Okay, so kalau kita dapat V23, kita akan dapat the voltage across the resistor number 3. Alamak, bukan 2, 3 lah, 1, 3. Astaga. Sorry if you are confused. But kamu label je lah ikut kamu punya understanding basically. Okay. So it's gonna be R13. Okay, this is just I1 lah. Okay, R13. Okay, betul sudah. So sekarang ni this is gonna be V13. So kita dapat the value of voltage for V13. Kita akan dapat the voltage for each of this resistor lah. Each of the resistor. So sekarang ni macam mana kita mau cari nilai yang ini? Kita akan cari salah satu di sini. Apa yang kita tidak? Kita perlu cari V2. Kejap. Kita mau cari ini, so kita perlu cari nilai voltage across resistor 2 and resistor number 4. So that is basically V13 equal to V minus V2 minus V4. So this is 20, this is IR. Okay, this is I1 R2, this is I1 R4. Kenapa kita guna I1? Sebab sekarang di sini apa yang flow di sini? The current that is flowing here is I1. So kita guna I1 lah. I1 across R1, I1 across R4. Okay? So di sini kita akan letak 2.96 2 ohm minus 2.96 4 ohm. Okay, so it's gonna be equal to 2.24 volt. So dapat V13, kita tahu dia akan equal to 2.24 volt lah for the voltage across resistor 3. So this will be equal to 2.24 over 3 ohm, which will give you 0.75 ampere. Okay? Alright, so that is how you solve this type of questions. So this is actually a past year question, so make sure you are able to do it, because this is basically the type of questions they will ask you in exam lah. Okay, if this subtopic keluar lah. Alright, so that is on subtopic number 5.